Hello and welcome back to Algebra 2/Precalc. Today we're going to try solving this equation for all real solutions. So let's get to it. This problem's a little tricky because if you just expand these guys out, you're going to get some super duper ugly polynomial. However, there's a trick to make this more doable. We can make a new variable a to be x plus 3. Now, why x plus 3? Because that's the midpoint between this guy and this guy. It allows us to write this guy and this guy as a minus 2 and a plus 2, respectively. The fact that we have the same number here, but one's plus, one's minus, is going to help us later on and make stuff cancel nicely. Okay, so how do we simplify these guys? One way is to FOIL them. This is a minus 2 times a minus 2 times a minus 2 times a minus 2. However, we can do it quicker using the binomial theorem. Well, when you expand this guy out, you get this expression. Here we know the coefficients are 1, 4, 6, 4, 1 by Pascal's triangle. Okay, but now what about this guy? Well, this is going to be the exact same thing, except with positive 2's instead of negative 2's. So let me copy paste this, but I'll change all the negative 2's to positive 2's. Okay, so this guy plus this guy has to equal 34. Let's see if I can squeeze in that equals 34 in here, barely. Okay, but now there's some nice canceling that's going to go on. This guy right here is going to cancel with this guy because one's the negative of the other. Likewise, this guy is going to cancel with this guy. When you have a negative number cubed, you're going to get a negative number, and so it's going to cancel with this. However, the rest of these guys are not going to cancel because when you have a negative squared or a negative to the power of 4, well, those become positive. So let's try to simplify this stuff. This becomes 6 times 4 times a squared. Okay, that's 24a squared. And similar with this guy here, this is also 24a squared. And negative 2 to the power of 4 is just the same as 2 to the power of 4, which is 16. And likewise, this guy is also 16. Okay, so let's simplify this. A to the 4th plus a to the 4th is 2a to the 4th. 24a squared plus 24a squared is 48a squared. And 16 plus 16 is 32. Okay, and this whole thing is equal to 34. All right, so this expression right here just simplifies to this. And now this looks awfully like a quadratic, doesn't it? Let's try to make the right side a 0 by moving the 34 over here. So subtracting 34 from both sides, we see it's logically equivalent to this. And now since all three of these guys are even, why don't we divide by 2 just to make our lives easier? This is logically equivalent to a to the 4 plus 24a squared minus 1 equals 0. Because of course 0 divided by 2 is just 0. But now we can use the quadratic formula to solve this, right? Just to make that a little more clear, note that this a4 is really just a squared, but squared. So that's logically equivalent to saying that this guy right here is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, but now we can simplify this a little bit. 24 squared is just 576. And then this part, okay, when you have minus and negative, you get a positive, so plus 4. So you get 576 plus 4, which just simplifies to 580. And now can we simplify the square root at all? Let's see. 580 is the same as 4 times 145. 4 is the same as 2 times 2. 145 is the same as 5 times 29. Okay, since there's a pair of 2's in the prime factorization, we can pull out a 2. So square root of 580 becomes 2 times square root of 145. And we know 145 can't be simplified anymore because these are both prime and not equal to each other. All right, but now we can simplify this. This is just negative 12 plus or minus the square root of 145. Okay, but now when you have a plus or minus, that's just an abbreviation for saying this or this. But guess what? This guy right here is always false. Why? Because x is a real number, right? And a is x plus 3, so therefore a must also be a real number. But when you square a real number, you either got to get a positive number or 0, but you can never ever get a negative number. However, this is a negative number, so you can't get that. So this is always false. So saying this is true or this false statement is true is logically equivalent to just saying that this guy is true. Okay, what next? Well, notice the right-hand side is positive, right? Because this guy is slightly more than 12. Recall, 12 is square root of 144. So square root of 145 has to be slightly bigger. Now, there's a theorem that says when you have something squared equals some positive number, that's logically equivalent to saying this equals the square root of this guy or negative the square root of this guy. Okay, so that means A is either the square root of this guy or the negative of the square root of this guy. And yes, you could write this with a plus or minus, but I'm just doing it this way to be super clear. But now what is A? A is just x plus 3, right? So it's the same as saying this. And now solve for x, we just subtract 3 from both sides. So x equals this guy minus 3, or x equals this guy minus 3. Or if you prefer, you can write it in more compact notation like this, okay? So these are the solutions to this equation. There's 2 solutions in all. Now, here's a question you may be wondering. Do we have to check for extraneous solutions? Do we have to plug both of these guys in to the original equation to make sure they actually work? And the answer to that question is no. The reason is because in this problem, I was very careful to make sure each line is logically equivalent to the previous line. Since we know each line's logically equivalent to the previous line, we've proven that this statement and this statement are logically equivalent to each other. So this guy is true if and only if this guy is true. And that's why you heard me saying logically equivalent over and over again. Since each line's logically equivalent to the previous, you could start here and step by step work all the way back to here. Like and subscribe if this was helpful, and I'll see you in the next video.